Hi everyone, welcome to the Quiz 3 review video. Today I'm going to be going through some important information for your quiz, some important concepts that I think will be really helpful for your quiz, and then I'll be solving 3 problems from the tutorials that I also think will be helpful for you during your quiz. So the first important piece of information is, when is your quiz? It is July 23rd from 2:30 p.m. to 4:40 p.m. EST time for all students, unless you have a time zone accommodation, which in that case you'll be writing July 24th from 7 to 9:10 a.m. again EST time. And you would have already been placed in group 2 if you are needing a time zone accommodation. If not, please contact us. The Quiz 3 is going to be covering concepts from Module 1 all the way to Module 7, so it is a cumulative quiz. So make sure that you're comfortable with all the concepts from the beginning of the course all the way up until now to Module 7, which is functions. The quiz is going to be 130 minutes, so this is 10 minutes more than Quiz 2, which was 2 hours. Quiz 3 is 2 hours and 10 minutes. So make sure you use your time wisely and split up your time between all the questions. Again, this quiz is an online exam, which is individual. Please make sure that you treat it with academic integrity and take the quiz by yourself. And the more specific guidelines about Quiz 3 are posted on the course website. We also made an announcement on Learn with the link to that, so you can find that on our course website, giving you all the detailed instructions about Quiz 3. And then just a note, some people had some questions about this last time. The quiz will appear in the S21 quiz group course, and then here it'll say your group number, so either group 1 or group 2. That's where it's going to appear. So when you refresh the page, you're going to see the quiz inside of this course, not where your homework is. So make sure you go to this course to see your quiz and not where you usually see your homework. Okay, so let's get into solving some of the questions, or let's get into some important concepts for Quiz 3.
The first important topic I want to talk about are built-in functions. So you guys have learned lots of built-in functions throughout the course. Things like sum, mean, median, sort, size, numl, and many, many more. My recommendation would be to make a list of all the built-in functions you guys have learned and maybe a brief description of their functionality. So something like, what inputs do they take and what outputs do they have? So for example, if they have one or more outputs, or if they accept one or more inputs. And an important note about built-in functions is that for their input arguments, they can accept vectors or matrices. So they don't just work on scalar values. You can also use built-in functions on vectors and matrices, which you've seen throughout Unit 5 and 6. So for Quiz 3, even though all of these quizzes are open book, so you can use your notes during them. Sometimes it might take a while to flip through your notes and find the function you're looking for if maybe you forget the exact like inputs and outputs it takes. So I would recommend take a little bit of time before your quiz and make yourself a little list about the some of the most important built-in functions. One I do want to talk about, or two, in comparison to one another, is the numl function versus the size function and the difference between them. So the numl function, it tells you how many elements in total are in an array. So if we use numl in this example on vec, here there are 1, 2, 3, 4, 5, 6 elements within vec. So this output, numl_vec, would be 6. Let's say we have mat1. If we did numl mat1, this isn't going to tell us, in this case, mat1 is a 3x3. It's a 3x3 matrix. This output is not going to be 3, so it's not going to tell us that, this is a 3x3 matrix. This is going to tell us how many elements in total are in mat1. So in this case, there are 9 elements, so this output would be 9. If you wanted to figure out what the number of rows or the number of columns are in a matrix, you want to use the size function. So here, as you can see, size is being used, and it has 2 outputs. The first one, you can label these outputs whatever you want. So you could call it row, column, size, mat1, or any other variable name. But what this tells you is the row dimensions, so like the number of rows is the first output, and then the number of columns is the second output. So in this case, each would be 3. You can also specify if you just want to know the number of rows. For example, you can use size mat1, and then to specify the number of rows, that's counting downward. So you would specify the direction 1. If you want the number of columns of mat1, you can specify the direction 2, and then that's counting how many columns you have, since that's counting in the horizontal direction. So that's the difference between numl and size, and I think that's an important distinction between these two built-in functions. And now I want to talk a little bit more about the different inputs and outputs for these built-in functions, and some of the things you might want to consider if you do make that list of built-in functions. So in this case, these are examples of the sum, mean, median, max, and sort functions. And this shows the different inputs and outputs they can have. So if sum can take an array as an input, and it will sum up if you just use sum on an array. So let's say we have this array, and this is equal to A. And this is a 3x3 matrix. If we do sum A, it's going to automatically assume that we want to sum in the vertical direction. So it's going to sum up all of the columns, and in this case, it's going to give us a 1/3 row vector in return if we just use sum directly like this. If we specify all, that means we want to sum up all of the elements within the array, and so it's going to return just a 1/1 scalar in return if we specify that we want to sum all the elements up. Or we can specify the dimension. So let's say we wanted to sum up in the horizontal direction, we would use sum A, and then we would specify 2, since that's the horizontal direction. And you can also specify 1, which would be the vertical direction. And so it's important to remember the input arguments and the output arguments for these for these built-in functions, so that you know if you're using sum, for example, you're summing up in the correct direction, or the direction you are intending to. And so the mean and median built-in functions have similar input and outputs, and sort and maximum, and also minimum, which isn't shown here, they have some additional output arguments and input arguments. So again, if you just took max of array A, it would again find the max in each column first, and it would report a 1/3 row vector. But if we wanted to take the maximum of everything again, you might specify all. If you want to take it in a specific dimension, you would specify the dimension, but in this case, you have to use empty brackets in between, because if you just did max A and then 2, this is then going to compare the elements in A and see if which is maximum, which is greater, like the element is being compared to, or the number 2. So this, we're saying empty brackets here, and then this is specifying the dimension. So if we wanted to find the max in the horizontal direction, we would specify 2. If we wanted to find it in the vertical direction, we would specify 1. And so these are the input arguments here. And then the output arguments, you can either just have one output argument, which is going to give you the maximum value. So it's going to give you, let's say if we take the maximum in the vertical direction for the first column, it'd be 4 and then 5 and then 4. So it would give you this vector. So this is immediately just going to give you the maximum value. But if you're interested in the index location of where that maximum is located, that would be specified with a second output argument. And so let's say you didn't care about what the value was, you just wanted to know that the max was in the second, and third locations. You can use this symbol, and then some variable name for your index, and then take max of A. And so this is another type of output argument for the max function. And same with sort. It can have two output arguments. So it is important to remember the different types of input and outputs that your built-in functions have, and that might be helpful to include in your list when you're making it. And so those are all of the, I would say, important tips regarding built-in functions. And like I said, I'd highly recommend making yourself a list of all of the built-in functions you've learned, so you have that handy during the quiz. The next important topic I want to go over are operators and vectorization. So in Unit 1, we learned a bunch of different operators, so things like addition, subtraction, transpose, and then we also learned relational operators and logical operators. So the relational operators we learned were equal to, not equal to, greater than or less than, and then we learned the logical operators and, or, and not. And so the important thing to remember about these operators is that a lot of them can be used on scalar inputs, but they can also be used on array inputs. So what I mean by that is, for example, if we have v1 and v2, if we use the equal to operation on them, what this is going to return is a logical vector that tells us which elements are equal to each other at the same location. So it's going to go element by element and compare in the same location. So here 1 is equal to 1, so we get a true or logical 1 value. 2 is not equal to 0, so we get false here. 3 is not equal to 1, so we get false, and then 4 is equal to 4, so we get a logical 1. And by doing this, we get a logical output. We can call this LG1, and this is a vector of the same dimensions as v1 and v2, and it tells us where v1 is equal to v2, so which elements are equal to each other. And another important thing to note is these two arrays have the same dimensions, and then the output is an array, again, of the same dimensions. And this works for the other relational operators too. So if we do v1 is greater than v2, we would get a logical output that looks like this. And again, this is a logical vector telling us false where v1 is not greater than v2, and true where v1 is greater than v2. The important thing to remember, though, is for the and or operators, remember, like we said in Unit 1, these operators work on logical values, but the double and the double or, they work on single logical values. So if we have true and false, this would give an output of false. But the two values we're comparing are a single logical 1 and a single logical 0. But we can also use the AND operator on arrays, on logical arrays, but then we would have to use the single and the single or operators. So for example, if we wanted to compare LG1 and LG2, and we did LG1 and LG2, we would get an error in this case since these are arrays and this double AND operator only works on scalar values. So we would have to use the single AND operator, and then the output for this would again be comparing the elements in the two arrays and seeing if we have a true and true. So in all these cases we have true, false, true, false, true, false. So we would get again an array of the same dimensions with a false in each location. And so again, it's really important to remember that the logical operators, they operate on logical values. So these two vectors need to be logical arrays for you to be able to use this AND operator. If you use it on double values, so if we did v1 and v2, this is not telling us, this is not the same as using the equal operator where we're saying, oh, where are v1 and v2 equal to each other? No, the AND operator, since it's a logical operation, is going to implicitly typecast these into logical arrays. So wherever we have a non-zero number, we would get 1, and wherever we have a 0, we would get false. And so this is a very different operation than what we did when we compared LG1 and LG2. This operation, again, only is a logical operator, so it should be used on logical arrays. Otherwise, if it's used on doubles, they'll get implicitly typecast. So these are some important things to remember when using operators. And all of this is important to consider when we then start talking about vectorizing your code and how we can use these logical array outputs to shorten our script. So if we go on here, we can start talking about vectorizing your code. And what that means is using these operators and getting array outputs and then using them to solve the problems we've been using instead of for loops. So this is a common example. We're trying to count the number of 5s in this vector, and normally we would do it using a loop statement. So we're going through all the elements in the vector, and then when that element is equal to 5, we would add 1 to num5, and then we're counting the number of vectors. But this script is a lot shorter, and I would say easier to write once we know how we can use our operators. So in this case, we're saying vec is equal to 5, and since 5 is a scalar value, what that's going to do is it's going to compare 5 to each element in vec and see if they are equal to each other. Before we said if we were comparing two vectors, we needed them to be the same dimensions. But here, because we're comparing a vector and a scalar, this MATLAB is going to know to compare this scalar to each value in vec, kind of like when we add a scalar to a vector. It's going to get added to each element in the vector. Same here with the equals operator, it's going to get compared to each element in the vector. And so when we do have two values that are equal to each other, we get a logical 1, either a logical 0. So now we have some logical array that has zeros where the value in vec is not equal to 5, and true or logical 1 where the value is equal to 5. So if we want to figure out the number of 5s, all we have to do is use our sum built-in function and count them up. And so this is a really useful way to shorten your script if you're able to, in these situations, use a logical array instead of a loop to solve the problem. And the other useful thing that we can do with logical arrays is logical indexing. And so what logical indexing is using a logical array to as an index, or to refer to elements in a vector. So here we've created this logical index which has true, false, and it's the same dimensions as v1. And if we use this as an index, so we're saying we're accessing these elements within v1, what's going to happen is wherever we have a true, it's going to extract this element, and we're assigning that value to v2, so we have a true in this location where the 4 is, so we see 4. Here we have a false, so this element does not get extracted. Here we have a true, so this element gets extracted, and then here we have a false again, so this element does not get extracted. And so logical indexing is again something really useful. Let's say you're trying to find, there are a lot of cases that you saw in your homework too, where you were trying to find what values were in certain locations. So for example, in your homework, if you were wanting to find the elements in the diagonal that were even and diagonal. So you were looking for what elements in my matrix are both even and diagonal. And if you somehow got a logical array that told you the location of the elements in the diagonal that were also even, you could then use that to access those elements and figure out what the values were, or assign them a different value by then using this logical array as an index for your matrix. And so that's why logical indexing is really useful in a lot of cases. And now I want to talk about logical built-in functions. And so these built-in functions are any, all, and find. These also work on logical arrays, so they take logical inputs, not double inputs. So here, for example, we have I1, I2, I3, I4, which are all logical vectors. And so any will report if any of the values are true, all will report if all of the values are true, and then find reports the location of the true indices. So here, for example, if we do any I2, it's all false, so there are there's not even one true, so it returns 0. And then any for I3, there are 2 true, so it returns yes, there's at least one true value. But then, for example, all will only return true if all of the values are true. And then find, in this case, if we do find I1, all of these values are true, so it returns the index of all of the elements. And if we do find I3, only the second and the fourth elements are true, so it returns the index. So that's important to remember about find, is that it returns the index of that true value. And but the other important thing to note is that in this case, I1, I2, I3, I4 are row vectors. And so any and all are returning one single scalar value, or one single value, either a logical 1 or a logical 0, either true or false. But what happens if the input is an array instead of a vector? So let's take a look at that. Here I have, again, my I1, I2, I3, I4, and in this line I've just concatenated them to make a logical matrix. So let's first take a look at the outputs when we use the any function on a vector versus a matrix. So this is my mat LG, what I've created here, that I've concatenated these logical vectors. And if I open up my LG1, LG1 is a single logical value that's reporting if there are any true values in I2, which is false since they are all zeros. But if I open up LG2, which was any mat LG, this is a 1 by 5 logical vector as an output. It's not just giving me one single output. Why is that? What it's actually doing is it, like the sum function, like the mean function, when it takes an array as an input, it automatically performs this function on the columns. So first it's checking, are there any trues in column 1? Yes, so my output is 1. True. Are there any trues in column 2? Yes, so true. In column 3, yes, so true. Column 4, true. Column 5, true, which is why I get an output that is a row vector that has the same number. It has the same number of elements as the number of columns in my mat LG. So what if I did in this direction? Now my LG2 is a 4 by 1 column vector, since now I'm checking if there are any true values within my rows. But let's say I wanted to figure out if there were any true values in the whole matrix. So if any of the values, if any of the elements in the whole matrix are true, how could I do that? What I could do is I could use the colon in this case, to specify that I want to look at all the values in mat LG. And when I do that, now my output for LG2, when I use the any built-in function, is just one value, either true or false. So that's the important thing to remember about the any and the all functions, is that on a matrix, it will automatically, when you use it, it'll search down the columns first. And so if you want to specify all of the elements, you would need to use a colon. So if we look at the all function on LG4, so this is on the entire matrix again, it is working down the columns first. And just like the any function, you can specify in the other direction, or you can specify all the elements for it to give you one scalar value. And now again, we looked at the find function for a vector. So here for I3, we looked at that example before. It gives us the location of the elements that are true, gives us the index location, and then what happens if we use it on this matrix, on mat LG? So if we open up LG6, in this case, it's giving us a column vector that is also including the location of the elements that are true, but it is in the linear indexing order. So in this case, this would be the first element, then 1, 2, 3, 4, 5, the fifth element. So let me just... So in this case, the fifth element is true, then the sixth, the seventh element, 8, 9, 10, 11, 12, 13, and so on. And so it's important to remember that in this case, we're using the find function. When we use the find function, it gives us an output of where the trues are located in linear indexing order. So those are the important concepts for operators, vectorization, logical built-in functions. So now let's talk about functions and creating your own functions. The final important topic I want to discuss is functions. This is a very important topic for your quiz 3 because essentially almost any question you've done before, you could make into a function. So think about any of your past homework questions, any of your past quiz questions. Almost all of them could be created into a function. So it's really important to understand what types of inputs and outputs the functions you create have, what the syntax for writing functions, and how they work. So first, let's talk a little bit about the input and outputs for your function. You guys know lots of different types of built-in functions that have all sorts of different inputs and outputs. They can have single input, single output, like the absolute value function. It just takes one value in and returns one value out. You could have multiple inputs and a single output. So this is randomly generating a number. It'll only ever have one output, but this is specifying, again, this is specifying different input values. Or you could have single and multiple inputs with multiple outputs. So for example, if you're finding the size of a matrix, in this case, it has one input and two outputs. You could also have you could also write this with just one output, size mat 1, and then specify the direction. So now it has two inputs and a single output. So there are different ways to use this built-in function, specifying either more than one output. You can have more than one input, one output, and then again, in some cases, you have functions where they don't have a return value. In this case, it's just going to print out this word in the command window. This type of function we don't deal with as often in terms of the types of functions you'll create, but any of these types are types of functions you have seen before and you've created. And the important thing is you guys are comfortable with using all these built-in functions. Hopefully you're comfortable with all the different types of inputs and outputs they have. And so it's no different when you're creating your own function. You will just have to define the inputs and outputs yourself. And then in the lectures, Prof. Yum talked about different types of functions. The type that we're going to be writing most often are the local functions, where in this case, you have a main function that is calling sub-functions or local functions. But we also see it often in our cases where we have some kind of script on top that calls a function, and then you have your function underneath. And so in these cases, right, your script is asking for an output or multiple outputs based on your function. It calls that function, and then you have created your function. And so again, this is really general, and I think it'll be helpful with an example to explain a bit more about functions. So let's show an example. This is just a question I chose from your tutorial. This solution is already posted on the class website for tutorial 7, for module 7. The actual question doesn't really matter, so I'm not going to talk about what the question is asking us to do. All I want to talk about is how, basically the syntax of functions, how we call the function, and then where we have to write our function, etc., and talk about the inputs and outputs. So the actual question doesn't matter, so I won't go over that, but let's talk about the important parts when we're writing functions. So in this case, we see in our first two lines, we have some 20 by 20 matrix and some random value. And here we are calling our function. So this part is our script. And here we are calling our function. And so here we're calling our function. We see our function, when we defined it, has two inputs, two outputs. Here we have two inputs, which are the values we defined here in our script, and we have two outputs that we're interested in calculating. If we run our script, as we see the outputs here, test max num, test min num, And we see the matrix we defined and the test num we defined in our script here. We don't see any of these variables getting printed in the workspace since they are within our function. So none of those get printed, just the script gets printed, or just the outputs of the script get printed. The other important thing to note is right here, the variable name of the inputs when we're calling the function aren't the same as right here when we're defining our function. And neither are the outputs. These are different variable names. How does that work? Well, the important thing to remember about functions is the purpose of, or why we make them is so that we can reuse them. It's for reusability, so we don't have to write the same script over and over again. And for that, we would want to use different variable names for the outputs of our function, especially if we're using it multiple times and want to get, we're testing it, different matrices with it. We want different output names. And so we want to be able to write different variable names for it. And it's a little confusing at first as to why these names can be different than these names, but think about when you're using any of the built-in functions. Let's say we're using the sum function on the testmat2D. What is the name of your output when you use the sum function? It's anything you want, right? You can name this output whatever you want. You use the sum function, and then you define, what array you want to sum up. And the name of this array, again, is whatever one you're testing, and the name of your output is whatever you wanted it to be. And so it's the same concept when you're creating your own function and calling that function. These names don't necessarily have to be the same name as the variable when you define the function. However, when you are defining your function, you have these input names have to be included somewhere in your script. These output names have to be included somewhere when you're defining your function, because essentially this function, when we're making it, when we call the function, this is telling MATLAB how to calculate the outputs. So we have to define our outputs somehow. We have to tell MATLAB, okay, this is how you calculate this output, the first output. This is how you calculate the second output. And so you have to use the names that are, these output names you have to include somewhere in your script, and these input names you have to include somewhere in your script. So it's basically, how do we use these inputs to calculate these outputs? That's what this function, that's what we're trying to do when we're creating this function. And so let's say what happens if I change the name of this output. All of a sudden, I get a little squiggly line under this variable name, and it says the function return value min_num might be unset. So that means I have not defined how I calculate this output here. I don't have this variable name within how I'm defining my function. And if I run my script, I get an error because I haven't defined this output. So MATLAB doesn't know how to calculate it since it doesn't have the same variable name. And it's the same if, let's say, I change the name of this input. Now all of a sudden, again, if I highlight this, it says input argument num_all might be unused. And if I run this script, I get an error since I don't use this input anywhere in my script. But I'm saying, oh, with this function, I'm using these two inputs to calculate these two outputs. And this is how. But I don't use this input at all anywhere since this is a different name. And so it's really important to remember that when you are creating your function, you have to use the input names somewhere in your function, and you have to define what your outputs are using these same names. So the next important thing to remember is when you're creating a local function, this local function should always be written underneath your script. So for example, if I try to write this function above my script, and then I start calling this function underneath, let's see what happens. I get an error. This statement is not inside any function. It follows the end that terminates the definition of the function. So what happens is we're trying to we always have to have the function underneath the call. It won't work to have the function above the script that you're trying that you're using. So you always have to have the function underneath your script for it to be able to work. And you would have seen in a lot of the homework questions for homework 6 that your given script was given to you up at the top, and then you had to write your function underneath. And so if you ever have to write script, you'll be writing it above the function. And that's another important thing to remember about functions and writing functions. So my recommendations, especially in terms of functions for quiz 3, would be really reviewing tutorial 7, unit 7 on how to write functions, the different types of functions, the types of inputs and outputs they can have, and how you can create or how you can change any of your script that you've written before into a function. So think about even some of the questions in homework 5, how you might be able to make them into functions. Maybe not all of them will be able to, but some you might be able to turn to functions. And that will be really important for quiz 3. So next, I'm going to talk about some of the questions from your tutorials and homework that I would recommend reviewing before quiz 3.
Alright, so now I just want to go through some questions that I think will be really helpful for you to study on your own. Before quiz 3, I'm going to go through 3 problems right after this and work through them step by step. But these are some additional problems from the tutorials and from your homework that I think will be really beneficial for you guys to study before quiz 3. So first, I'd highly recommend watching the quiz 1 and the quiz 2 solution videos that Professor Yum recorded and posted on the course website. I think you'll find these very helpful for quiz 3 as well. Keep in mind, if you see a question often on your quizzes, I would highly recommend reviewing it for quiz 3. And also, make sure you study homework 5 and homework 6. Your quiz will be based off of all modules 1 to 7, but I would definitely emphasize studying modules 5 to 7, which were included in homework 5 and homework 6. And then, of course, in addition to watching the quiz 1 and 2 solution videos, also redoing the past quizzes I think will be really beneficial. And when redoing any of these questions or any of the tutorial questions, my big suggestion would be think about how you can maybe vectorize those solutions if they were initially written with loop statements. Maybe you can think about how could I write this with vectorized code instead of a loop to make it more efficient, or think about how you can create a function for that problem. A function can be created for almost any problem. So think about when you're redoing some of your old problems, could this be something that is repurposed or changed into a function? And I would really recommend that when you're studying for the quiz. Think about how you can make any of these problems to include a function. And then here I've included some problems from modules 1 to 7 that I think will be helpful for you to review. Specifically thinking about these earlier modules, so modules 1 to 5 before you learned how to vectorize your code. You can think about how you can vectorize your code in these modules, or specifically, for this one, how to solve it without loops. Try to vectorize this one. And then here are some important ones from modules 6 and 7. All right, so now let's get into actually solving a few problems that I think will be really helpful for your quiz.